Well, welcome back, class, and we're going to be discussing the refrigeration diagram. We're going to be discussing the states of the refrigerant as we go through this. We're also going to be discussing the components that make up the refrigeration process: high pressure, high temperature vapor, high pressure, high temperature liquid, low pressure, low temperature liquid, low pressure, low temperature vapor, as it's moving throughout the system. And the whole premise of the refrigeration system is to move heat from a place I do not want it and to place that heat in a place where it makes little or no difference that I've placed that heat in that area. So this particular PowerPoint was created by uh, Mr. Baldoff. So let's go ahead and get into the different states of the refrigerant and the different components that make up the refrigeration process. So we're going to be talking about the refrigeration cycle. First thing that we want to do is we want to draw these circles for our refrigeration cycle. So follow along with me. So these circles right here are indication of the four major components that are on our system. Now, as the refrigerant is flowing through these four major components, each one has a job to do. And if we were to lose one of these components in the system, we would lose the ability for the refrigerant to absorb heat and to take that heat from a place that we don't want it. To absorb that heat and to move that heat to a place where it makes little or no difference that we have that heat in there. So go ahead and draw those four different circles for me. Draw the lines that are connecting those four circles. Draw you don't have to worry about these rectangles in here. That's more for the refrigeration class. So just draw the straight lines going up to the different components that are there. And we will discuss the different refrigerant states that are in this particular system. So when we look at the different states of the refrigerant, I always like to refer it back to water, and as water's absorbing heat and rejecting heat, what happens to that water. And when we look at this refrigeration diagram, what we're actually looking at is what these four components are doing to the state of the refrigerant as it's moving through the system itself. Every component named in the refrigeration cycle is named for the things that it does to the refrigerant, either absorbing heat, such as our evaporator, or rejecting heat, like it does in our condenser. The compressor is very self-explanatory, as in its purpose is to compress the refrigerant from a lower pressure into a higher pressure, and to move that refrigerant throughout the entire system, creating on one side of the system a high pressure and creating on the other side of the system a low pressure for us. Hopefully by this time you have drawn the four different circles within the refrigeration diagram. You've connected those circles with the lines that are running between the two, and we will get into the states of the refrigerant. Okay, here's the compressor towards the bottom of it. So uh, hopefully you have these all drawn for me. We're going to go ahead and erase all that. I want you to look up here to the upper left hand corner. We're going to be putting these different states of the refrigerant on our top left of our diagram themselves. So go ahead and put a triangle in there, and that triangle is going to be a solid red, and that's going to indicate the high pressure, high temperature liquid as the refrigerant's moving throughout the system. We're also going to be having the high pressure, high temperature vapor, and those are going to be red lines, but they're going to be in a diagonal fashion as we are moving ourselves throughout the refrigeration diagram. Go ahead and put the low pressure, low temperature liquid on that diagram. The key is what we're calling that upper left-hand portion up there. That's low pressure, low temperature liquid. And we have dashed lines for our low pressure, low temperature vapor as it's moving throughout the system. Another thing that I would like you to draw on it is these dividing lines right here. We have two dividing lines. One's going to be towards top of the diagram, splitting it right down the middle, and the other portion of it's going to be on the horizontal axis right here. Now let me discuss a little bit about this horizontal axis that we're looking at on this refrigeration diagram. It's indicated by that dotted line that's on it. So go ahead and draw that on your piece of paper as well. And let me kind of explain what's going on within this diagram. There are four major components on this diagram: compressor, condenser, metering device, and evaporator. Within the four major components, we are divided into a liquid refrigerant, we are divided into a vapor refrigerant. Everything to the bottom of the dashed line that is indicated right here is in a vapor state. And that's very important for us to understand because our compressor is a vapor only pump. So it's bringing vapor into it, and it's expelling vapor from it, compressing that vapor out of the system. I'm sorry, compressing that vapor through the system. It's sucking it from the evaporator into the compressor and then moving that refrigerant into the condenser itself. Up towards the upper portion of this diagram, we still have that dividing line that we're looking at right there. Everything on the upper portion of the diagram, it's in a liquid state. Now, I just want you to draw the cross. I don't want you to draw anything else. I'm labeling them as liquid and vapor so that you might better understand what's going on within the system and why we put those dividing lines in the system. So everything on the upper portion of this diagram is in liquid form, where that liquid form is a high pressure, high temperature liquid or a low pressure, low temperature liquid on the left-hand side of the diagram. And the next thing that we want to do within our diagram is we want to draw a line straight down the diagram on the vertical axis. And that's that dotted line that you're seeing. So just draw a dotted line right down the middle. I've highlighted it pretty well with the black marker there so that you might understand that everything on the left-hand side of that diagram is in the low pressure state. So everything on this side is low pressure, and everything on this side is a high pressure refrigerant. That's very important when we're trying to absorb heat in the system and to take that heat to the other side of the system. And I want you to think of it this way, that everything that's a low pressure within our refrigeration system is a low temperature. Everything that is a high pressure within the refrigeration system is a high pressure. Well, hopefully you've had time to draw out the diagram now and draw out the key that is in the upper left-hand portion of the diagram itself. Let's go ahead and erase the rest of that. Remember, everything on the left-hand side is low pressure. Everything on the right-hand side is high pressure. It's also indicated by the colors of that refrigerant as we are drawing it within the system. Everything on the bottom half of the diagram is in vapor state. Everything on the top side of the diagram is in liquid state. So we're going to start off with this compressor right here. The compressor is at the bottom of our diagram. And what comes into the compressor is a low pressure, low temperature vapor. On the other side of the compressor, we're going to take that low pressure, low temperature vapor. We're going to compress it. And by compressing it, we're actually going to increase the pressure on that refrigerant itself. So we're going to go ahead and take our lines on our compressor and we're going to make them dashed on one side of the compressor. Remember back when we were looking at the sides of the diagram that this side of the diagram is high pressure and the other side's low pressure. So we're going to use our key and we're going to show the state of the refrigerant as it's moving through the system. One of the things I like about the refrigeration cycle, the refrigeration diagram, is that every component within the diagram tells you exactly what the component's doing to the refrigerant itself. it's compressing it. So the compressor is creating flow within our system and compressing that refrigerant. Also within this line, which is referred to as the hot gas line, which runs in between the compressor and the condenser, the state of the refrigerant within that will be a high pressure, high temperature vapor as well. Now we like to use the crosses on the diagram as the dividing point. As we are coming into the condenser, the refrigerant state will be a high pressure, high temperature vapor as it's heading into the condenser itself. And that will be indicated by the dashed lines that we are using based off the key that is found in the upper left-hand portion. Now, going back to our analogy of like water, as the refrigerant is coming into the compressor, it compresses it. Vapor in, vapor out. High pressure, high temperature vapor is going to be pushed into the condenser. Now, the purpose of the condenser is to take the heat that was absorbed in the evaporator and to remove that heat from the system. Now, water, if you add heat to it, will turn into steam, vapor form. And then as you remove heat from the water, the vapor will turn back into a liquid form. This side of the system is high pressure. So as the refrigerant is going through our lines, compressed and then turned into a high pressure, high temperature vapor, we come up to the condenser. And the condenser does exactly what the condenser says it does. It condenses the refrigerant from a high pressure, high temperature vapor into a high pressure, high temperature liquid. So we're going to take the circle on the other half and we are going to color in the entire circle on that half, showing that in the condenser that it condenses the refrigerant into a high pressure, high temperature liquid. It's also going to flow through this line right here. Kind of hard to pick up the red against the other red that's sitting there. We're going to go ahead and color that in because the condenser, as the refrigerant is moving throughout the system, is going to turn it into a liquid. And then we come up to our component that divides the low and high side of the system, just like the compressor does, and running all the way up to the metering device or the expansion device is a high pressure, high temperature liquid. Go ahead and color that in on the diagram that you are doing at home so that you understand what the state of the refrigerant is within the system. So with the refrigerant moving from the compressor all the way up to the metering device, the compressor is going to be creating a low side pressure on one side of the system and a high side pressure on the other side system. So our dividing marks within our system happen to be right down the line over here. So everything on the right hand side is going to be a high pressure vapor coming out of the compressor, condensed in the condenser to a liquid because it got rid of the heat. Much like when you take steam and remove heat from it, it will turn back into water. The refrigerant inside the system, once it goes through the condenser, will release the heat and turn from a high pressure, high temperature vapor into a high pressure, high temperature liquid. Our metering device is one of the dividing parts of our system. On one side of the metering device is a high pressure. On the other side of the metering device is a low pressure. And when you change from a high pressure to a low pressure, you are changing the temperature of that refrigerant as it is passing from one side of the system into the other side of the system. Whenever a certain pressure will give you a certain temperature within the refrigeration system. And that is basically what the metering device is doing for us. It's sending the refrigerant through a really small hole, high pressure on one side, and then expanding it And that's one of the reasons why they call it an expansion valve, because that refrigerant, as it's going through that really small orifice on the metering device, will expand into a very large area. And the pressure of that refrigerant will go from high pressure to a low pressure. Now, when that happens, the refrigerant temperature will also drop within that system itself. So, coming out on the other side of that refrigerant system, out on the metering device, so as we were going through this system, we're up here at the metering device, or the expansion device, as the book likes to call it. I always refer to it as the metering device because it tells me exactly what that device is doing. It's metering the refrigerant. And then the expansion device also makes sense to me because we're taking that refrigerant and we're expanding it into a very large area. Now, what that does is it takes a very high pressure, high temperature liquid and drops the pressure on it and drops the temperature on it so that we can absorb the heat within that system. So it goes through that metering device and then it expands. And when you expand a gas out into or a liquid out into a very large area, that vapor will drop in pressure and then will drop in temperature so that we can absorb heat on that metering device. So on the exit of that metering device, we're going to come in here and we're going to be a low pressure, low temperature liquid. So we're going to go ahead and color in all this over here and make sure that you're doing this on the paper that you have to turn into me on the first week. Go ahead and color it all in. And that's just signifying with the key that on this side of the metering device, which divides the discharge side and the suction side, or the low side and the high side, that all of this refrigerant coming through here is going to be a low pressure, low temperature liquid. Now I want you to start getting into your mind that when it's high pressure, it's high temperature, and when it's low pressure, it's low temperature. So as we are continuing moving through our system and coloring that up, make sure that you get every corner and stuff. I'm going to go through and that's going to be good enough for me. Now, right in the middle of the evaporator, and this is the next device that we have sitting here, it's called an evaporator. Remember, things within our system do what they are named. The compressor compresses, the condenser condenses, the metering device meters refrigerant, or the expansion device expands it into a very large area, and then the evaporator will evaporate that refrigerant. How is it going to do that? Well, think about water again, and we have to add heat to water to get it to turn from a liquid state into a vapor state. Well, our refrigerant is a very low pressure. Our refrigerant is a very low temperature. And as that 90-degree heat from the air is passing over the evaporator, heat will always move from that which is more hot to that which is less hot. And then that liquid refrigerant will absorb that heat and boil. It will evaporate from a liquid into a vapor. So on this side of the evaporator, we're going to put these dashed lines, and that's going to illustrate for us that on this side of the evaporator, that has taken that liquid refrigerant that came to it from the expansion device, and it has turned it into a vapor. And that's really good. That's perfect for us because we have a vapor only pump at the compressor, and if we were to send any liquid into our compressor, we would end up destroying that compressor itself. So there you go. That's the states of the refrigerant as it's passing through the different components of the system. You might have noticed as well that at the top of the system I have put in discharge and I have put in suction at the top of our system. So that way you know that the dividing on the left hand side of this is all low pressure and on the right hand side of this is all high pressure. And that's important. So when we're going through and looking at different components that we have on our system, that we can understand that that component is on the high or low side, that component has vapor or liquid refrigerant in it, but also that component is performing something to that refrigerant so that we are capable of moving heat throughout the system. Well, let's go ahead and go through the different functions of the different components that we will find on the refrigeration system. The compressor has 6 jobs. One of the jobs of the compressor is to create flow. I always like to think of the compressor as the heart of the system because without your heart, you wouldn't be able to do you wouldn't be able to do a lot. So the compressor is the heart of the system that creates flow of the refrigerant on the inside of the system itself. The compressor is also a vacuum machine. It's actually producing a low pressure condition on one side of the system and a high pressure condition on the other side of the system, which gets us to the third job that the compressor actually does, which is the compression machine. And also, the fourth job builds head pressure. The compressor does divide the system, divides discharge and suction side, and it is a vapor only pump. One of the jobs of the evaporator is to take the liquid refrigerant that's coming into it, absorb the heat from the air, and then to vaporize the liquid refrigerant before it gets back to the compressor. Now, there are a couple of different items that help protect the compressor if any liquid refrigerant was to come back to it. But it is a vapor only pump, and if any liquid refrigerant was to end up inside of the compressor, we could end up with damage, especially on the reed valves. There are certain compressors that can take liquid refrigerant better than others. Rotary compressors do not take liquid very well. Reciprocating compressors, uh, they'll blow up the reed valves on them. So, and on commercial refrigeration, you have to be careful about that. Small compressors, you have to be careful about that. When we're talking about air conditioning and our heat pump systems, many times we're using a Copeland scroll compressor, and the Copeland scrolls are an excellent compressor that will actually separate out the scrolls to prevent the liquid refrigerant from damaging the compressor itself. But for the most case, the compressor, which is at the bottom, is a vapor only pump. Well, we're continuing on. And as we can see, I want you guys to go ahead and write those 6 jobs of the compressor down. Just number them off to the side, maybe in this area here on your piece of paper. And just number 1, 2, 3, 4, 5, 6. And then we'll go ahead and get, when you send that to me in an email, we'll go ahead and look that over and make sure that you've done the diagram correctly. Now, as far as the next the refrigerant flow is concerned, we are heading in this direction right here. Now, this line right here is a discharge line. So the compressor is going to take that low pressure, low temperature vapor that's very heat laden, a lot of heat in that vapor. It's going to compress it into a small area. It's going to raise by pressurizing that refrigerant, we're going to raise the temperature of that refrigerant to a place where we can remove that heat from that refrigerant as it's going to be passing through our next component, which is our condenser. Now, here's our condenser. The purpose of the condenser is to take the heat out of the system. Don't forget that on your diagram to go ahead and put these arrows in by the condenser, showing us that the heat is actually leaving the condenser. The heat is leaving the refrigerant, and it's going to be passed from the refrigerant into the air temperature that's passing either outdoors over the condenser. So that refrigerant is going to be much hotter than the air temperature is. Remember that heat always moves from that which is hot to that which is less hot. So we're removing heat from the condenser. Another job that we can think about the condenser doing is taking that vapor refrigerant that we have and then turning it into a liquid. And how does it do that? Well, I go back to the example of water and how steam can be turned back into liquid water by removing heat from it. Well, the same principle goes into the vapor refrigerant that's passing on the inside of our refrigeration system. The condenser takes that heat, gives it to the air outside, and then the refrigerant will change states from a vapor back into a liquid because we have removed the heat from that vapor. Now there's three jobs that I want to look at the condenser actually accomplishing. Number one is the condenser changes a high pressure vapor into a high pressure liquid. The second job that the condenser has is removes the heat. And then the third job is it takes heat laden vapor in, and then as it is leaving the condenser, we are going to have cooled liquid coming out of it. Now, is it cold? Yes, it's colder than what it was coming in, but it is still a high pressure, high temperature liquid refrigerant as it's going to be passing on to our next component. So make sure that you are putting the three jobs of the condenser down for us. Don't forget about those heat arrows over there, and then also write in there heat for me so that we can see that you're getting the concept of the refrigeration cycle as it's passing through the system. Well, the next component that we are going to be dealing with is the metering device. Now, the metering device does exactly what it says it does. It meters the refrigerant into the low side of the system. On one side of the system, you're going to have a high pressure, high temperature, subcooled liquid refrigerant passing to the metering device. And then that metering device or expansion device is going to take it and push it through a really small orifice. And then on the opposite side, it's going to expand out into a large area. Now, that metering device meters that flow of refrigerant. Another name for the metering device is expansion device. And also another job of the metering device, it's going to divide the low side of the system from the high side of the system, or divide discharge side and the suction side. So those are the two jobs that I want for the expansion device or metering device, is that it meters the flow of refrigerant and it divides the discharge and suction side. To give you an example of what I can think of to show you what happens when the refrigerant meters through the expansion device, is if you were to take the air dust can, tip it upside down, what you would have on the inside of that would be a high pressure, high temperature liquid. Now, as you were to depress that air duster, you would feel liquid refrigerant coming out of it. And then what happens to it is it expands into this large area. As it does that, a large pressure drop happens on the refrigerant. And as that refrigerant pressure drops on the refrigerant, the temperature as well will drop on that refrigerant. Now, within our system, within our refrigeration system, this is very important because we are trying to absorb heat from the air that's passing over. And the only way that we can absorb heat from a house, from a car, from our food in our refrigerator is if that refrigerant is colder than the actual product that we are trying to cool, such as air or food in the case of a refrigerator. So as we drop the pressure on that refrigerant by metering it, and also the compressor pulling that refrigerant back, we create a low pressure condition in which that refrigerant will be able to absorb more heat in the next component that we are going to be discussing. So the refrigerant is flowing in this direction from the compressor to the condenser. The condenser does exactly to the refrigerant what the condenser says it does. It condenses it by getting rid of the heat. And then moving on up to the metering device and the two jobs that the metering device does for us, or expansion device, and the two jobs that expansion device does for us are put down there. Now let's discuss the fourth component within the refrigeration system itself. Now, as we look at this fourth component, it's called the evaporator. And like I said, I love the refrigeration diagram because every component is named for what it does to the actual refrigerant that's in that component. So the evaporator does what? It takes a low pressure, low temperature liquid, Remember that liquid refrigerant is colder than the media or the air passing over the evaporator. So the hot air will give its heat to that colder refrigerant because heat always moves from that which is hot to that which is less hot. So the evaporator takes that liquid refrigerant, low pressure, low temperature liquid refrigerant, and it will absorb the heat of the air and it will sit there and boil that refrigerant into a vapor. So one of the jobs that the evaporator does is it changes low pressure liquid into low pressure vapor. And I want you guys to get into the habit of thinking low pressure, low temperature, high pressure, high temperature. So the two jobs that evaporator are going to do, it's going to change low pressure liquid into low pressure vapor, and it's going to absorb the heat from the air or the product that is passing over it. Please don't forget to put my heat arrows in the evaporator itself. Make sure to write out heat on your diagram as you are drawing it out so that you can understand what's going on within that system. The refrigerant is going to continue along that path from the compressor to the condenser, from the condenser to the metering device, from the expansion device or metering device into the evaporator, and then from the evaporator back to the compressor. Now, this is a renewable process. Refrigerant can be used over and over again. We don't have to worry about using that refrigerant up. It's not like gasoline. It's not like gasoline in the sense that when you drive your car, you are using gasoline to accomplish movement with that vehicle. But refrigerant is renewable as long as we can keep it inside of our refrigeration system. Then we can reuse it over and over and over again. An employer I used to work for had a great saying: refrigerant doesn't use out, it leaks out. So once we have leaked out the refrigerant, the process of heat transfer can no longer take place within our system. So that's what's going on when you end up losing refrigerant out of your system. You actually lose the ability to move heat throughout the system because the transfer liquid, such as the refrigerant, isn't in the system anymore. So we can't absorb that heat and we can't reject that heat as it's moving throughout the system. So as you continue on drawing out your diagram, there are a couple of other things that we need to add to this. I will go over the rectangle boxes that are between the condenser and the metering device and the evaporator and the compressor. You won't see them on every system, but you might see them in a couple of different systems, such as vehicles, refrigeration, heat pumps. Not so much in your air conditioning systems, but you will see those. So, well, let's continue on. So you got the four components: the compressor, the condenser, the metering device, and the evaporator. The refrigerant's flowing from the compressor into the condenser, from the condenser to the metering device, from the metering device into the evaporator, and then from the evaporator back into the compressor. And the whole job of the system is to move heat from a place where we do not want it to a place where it makes little or no difference. Now, there are a couple of things that we need to look at. This one right here, I know my face is over top of it, but it is the discharge line. Okay, so if you want to write discharge line in there, and what the discharge line is it is a line that is between the compressor and the condenser. So our discharge line happens to be right here. So it's the pipe that is connected between the compressor and the condenser, and the flow of refrigerant happens because of this pipe right here. Now it's very, very, very hot. Most times it's going to be 110 degrees above the ambient temperature outside. So if you're looking at a 90-degree day, well, this pipe right here could be upwards of 200 degrees as it's flowing throughout the system. You can see that's a tremendous amount of heat as it's entering into the condenser for the condenser to be able to get rid of that heat on there. Another line that I want to look at is up here between the condenser and the metering device, and that is our liquid line. Now that's the line that's running in between here and here. That's not that rectangle, and I'll go over that rectangle in a little bit, but it's the line that is connected between the condenser and the metering device, and that is a that is a high pressure, high temperature, subcooled liquid refrigerant flowing into the metering device. Now, after it leaves the metering device, we have another liquid line, but we notice that that liquid line is on the left-hand side of the system. And remember our cross and our dividers in there, that everything on the left-hand side of this system happens to be in a low pressure, low temperature liquid form right here. So the line that is connected between the metering device and the evaporator is the low pressure liquid line. Now this line isn't as long as some of our other lines. Sometimes we put our metering device or expansion device right on the evaporator. So that line's not very long when we're looking at it on a system itself. So as we're going through, we'll go ahead and distinguish where the suction line is, and that's that line that runs between the evaporator and the compressor. That's the line that usually runs from the indoor of the house out to the condenser. That's the larger of the two lines sitting there. And then we have another line called a liquid line, high pressure, high temperature. That's the smaller of the two lines that it's running between our systems. Now, those lines connect all four of these components, and that is what it's enabling us to move the heat throughout the system. So go ahead and put those lines down for your drawing, and then we'll go ahead and you'll email that to me at the end of this presentation. I am going to go over these parts right here and this part right here in our next slide. Well, the last component that I want to go over, or the last two components I want to go over, are found right here and right here. Now, not every system has this. Automotive air conditioning, you will have one or the other. Refrigeration, you might have both of these actually within the system. And it depends on the type of metering device that you have in the system that dictates whether or not you will put these two components within the system. The four major components stay the same throughout the entire system, yet these components can be added or removed from the system depending on how the manufacturer wants to run them. So we will start with this first one up here, and it is the receiver dryer. So that rectangle right there is a receiver dryer. Now there's four things I want you to know about the receiver dryer. It stores excess liquid refrigerant. Now, the purpose of that is if you have a TXV system, that the TXV system will monitor how much heat's being absorbed by the evaporator. And it will add liquid refrigerant to the evaporator or hold liquid refrigerant back. And when it holds that liquid refrigerant back because the superheat on the evaporator is low enough, when it does that, it needs a place for that liquid refrigerant to back up into. And that's what the receiver dryer is for. It's there to store the actual liquid refrigerant. Now, in automotive air conditioning, it will filter and it will dry the actual refrigerant. And it's found only in automotive on TXV types of metering systems. But in refrigeration, air conditioning, heat pumps, the receiver dryer is just a storage device that is storing that liquid refrigerant until the TXV needs it for the evaporator itself. The next device I want you guys to understand, it's right down here on the suction line, and we are referring to it as the accumulator, and that's that rectangle piece on the low side of the system. In automotive air conditioning, it will store, filter, and dry, and it's only found on the dumb metering device, which is the FOT, which is a fixed orifice tube. I say it's dumb because all it does is it has a single orifice that does not change in dimension. It does not care what's happening inside the evaporator. And because it is that type of metering device, we need to have some sort of protection for our compressor. Now that compressor is protected by the accumulator. If the liquid refrigerant was to flood into that evaporator and we were to get a really low superheat, the accumulator would sit there and boil off the excess refrigerant boil off the excess liquid refrigerant before it would enter into our compressor and damage our compressor. So the four jobs of that accumulator are they store, they filter, they dry for automotive, and it's only found on FOT metering device systems. As far as refrigeration is concerned, air conditioning, commercial refrigeration, the accumulator is just there as a protection device that stores liquid refrigerant until it can boil off into a vapor. So hopefully you have all of these different jobs of the refrigeration cycle down. Make sure that you are color coding where you need to, writing out the particular jobs that every unit has and the purpose that it has for it. And you will email that to me in the assignment that's on uh, Canvas so that I can take a look at it and make sure that you've watched the entire video and have uh, completed the refrigeration cycle. I hope this explanation of it was beneficial to you, understanding the four different components, the four different major components of the refrigeration cycle, but also how it's moving heat throughout that cycle, and that it is a renewable process. I'll get used to it because our government is going to mandate heat pumps be installed instead of gas furnaces. So understanding the refrigeration cycle is going to be very important for you to understand. Well, I hope you enjoyed this PowerPoint. Go ahead and fill it out and send it to me, and look forward to seeing you guys later.